If you strip away the casing of a modern nuclear power plant, or look inside the engine of a commercial jet aircraft, you will find the exact same physical mechanism generating power. But humanity did not discover that mechanism during the Industrial Revolution. In 50 AD, a Greek engineer built a working steam engine, fired it up in a temple, and used it as a magic trick. The crowd clapped, the engine was set aside, and humanity lost over 1,500 years of technological progress. The engineer was Hero of Alexandria. He lived in Roman Egypt during the 1st century, teaching mathematics and physics at the ancient equivalent of a university. While the famous philosophers of his era believed truth came strictly from pure thought and debate, Hero believed in building physical machines, testing them, and recording the results. His surviving notes read like the portfolio of a time traveler. 1,800 years before the United States installed its first commercial vending machine, Hero built a coin-operated brass box that dispensed holy water in temples. He designed pneumatic systems that made heavy doors open by themselves, and even constructed a programmable mechanical cart driven by a binary system of knotted ropes. But his masterpiece was a device called the Aeolipile. A heated kettle at the base generates vaporized water, or steam. That steam travels up 2 vertical pipes and pressurizes a pivoting hollow sphere. The steam then vents out through 2 directional nozzles bent at right angles. When the fire burns, the sphere spins. Hero documented this machine in 50 AD. James Watt did not patent his improved steam engine until 1769. That is a gap of 1,719 years. The Roman Empire had the intellectual capacity to harness steam power. They had the metal, they had the math. So why did they fail to start an industrial revolution? To understand the failure, we have to look at the physics. As the gas pushes out in one direction, it creates an equal thrust in the opposite direction, forcing the sphere to rotate. This is Newton's third law of motion reactive force, where an action creates an equal and opposite reaction. Hero demonstrated it 16 centuries before Isaac Newton was born, using the identical principle that propels a modern rocket, and it was incredibly powerful. The Aeolipile's rotation speed pushed past 1,000 RPM, or revolutions per minute. For context, that is faster than the idle speed of many modern car engines, but that extreme speed created an engineering paradox. To do heavy industrial work, a machine needs torque, the rotational force that can push or pull massive weight. Because Hero of Alexandria's sphere spun so fast on a free axis, its torque was extremely low. If you tried to attach a heavy grinding wheel or water pulley to it, the friction at the steam joints would simply stall the machine. Instead of venting steam to spin a sphere, modern machines direct steam into a sealed iron cylinder to push a heavy piston up and down. That linear pushing motion is then converted into massive rotational force by rigid levers and massive gears. It is heavy, slow, and remarkably strong. The Aeolipile was a masterclass in aerodynamic physics, but for heavy industry, it was a mechanical dead end. To extract useful work, the Greeks needed to make the conceptual leap from a spinning radial turbine to a pushing piston system. They were highly capable of making that leap, they just had absolutely no economic reason to do it. At the height of the Roman Empire, historians estimate that enslaved humans made up 30 to 40% of Italy's entire population. Slaves worked the deep mines, operated the agricultural mills, and provided nearly all manual labor. This represented the brutal financial math of ancient innovation. A hypothetical steam pump required an enormous upfront capital investment in specialized copper, high-quality iron, and highly trained metallurgists, plus the ongoing cost of harvesting and transporting wood for fuel. On the other hand, human labor had a one-time purchase price from a slave market and required only the bare minimum of grain to keep them alive. It was drastically cheaper to own a human being than to build a machine. This economic reality bred a profound cultural contempt for physical labor. Greek and Roman elites viewed manual work as an activity strictly for the lower classes and the enslaved. Brilliant engineers like Hero had intense social incentives to present their inventions as magical entertainment or philosophical toys. Presenting a machine as a practical tool to replace human labor was a social risk. The state itself was actively hostile toward labor-saving devices. According to Roman historians, an inventor once presented Emperor Tiberius with a form of unbreakable, flexible glass. Instead of rewarding the man, Tiberius had him executed. The emperor feared that indestructible glass would devalue the artisan trades, put coppersmiths out of work, and destabilize the rigid hierarchy of the working class. The ancient world did not lack the intellect to build engines, nor the materials to forge them. The early industrial revolution was suppressed by a social order that relied on forced human labor and viewed massive mechanical efficiency as a direct threat to aristocratic control. After the fall of the Western Roman Empire, the intellectual tradition of Alexandria fragmented, but the Aeolipile was never truly lost. Hero of Alexandria's textbook survived through the Middle Ages in Byzantine and Islamic manuscripts. European scholars in the Renaissance even built replicas. Yet it remained a desk toy. It took an acute crisis to force humanity to finally scale up steam power. England was running out of surface wood, forcing miners to dig deeper coal shafts that constantly flooded with groundwater. Human and animal labor simply could not haul the water out fast enough. They needed a mechanical pump. Once that singular economic problem demanded a solution, innovation accelerated. In a matter of decades, steam machinery covered the globe. Technological revolutions do not happen simply because a scientist discovers a new mechanism. They happen when scientific knowledge collides with an undeniable economic necessity. If an emperor had simply directed Huron's engineering successors to solve that flooding with a piston-driven steam pump in 100 AD, coal mining and steam power could have advanced in tandem. Hundreds of millions of human beings lived in chains simply because it was cheaper than building boilers. We are currently surrounded by discoveries of massive potential, artificial intelligence, genetic engineering, quantum computing, and nuclear fusion. Like the Aeolipile, these tools face intense pressure from incumbent industries desperate to protect their market share, and governments anxious to maintain social stability. Human progress is rarely bottlenecked by our capacity to invent. It is bottlenecked by our societal permission to change. Heron's spinning copper sphere is a permanent monument to that truth. The physics worked perfectly. The machine did not fail. The civilization did.